Hi, my name is Paul Burdett, and I'm with the Cisco Security Group. Now, as we discussed in our introductory and overview video, how Cisco Identity Services Engine, or ISE for short, enables your zero trust workplace through consistent, secure network access across wireless, wired, and VPN connections. You learned how ISE delivers a scalable network segmentation that quickly adapts to contain threats. Now, let's see this in action. When you first log in, ISE immediately presents you an overview of all your network resources. Across the top are key endpoint metrics. We get a look at total endpoints, active endpoints. If we had any rejected resources, we'd see them here. Also the same for anomalous behavior. And if we click this button on the right hand, we can get a little bit more details. We can look at all of our authenticated guests and also all of our BYOD endpoints. Here we're looking at the Authentications box. ISE also authenticates endpoints to ensure they are who they say they are. So the Authentications box presents this summary. Now we're going to talk more about this in a moment. Let's move on over to the Network Devices box and see what's over there. In this view, we see all network infrastructure devices like routers, switches, and those wireless access points. Now, ISE tracks more than just endpoints. To control access, it's important to have visibility across your entire network. Now, the endpoints box is just what you'd expect. Here we're seeing devices like laptops, mobile, and IoT devices. As we discussed, ISE classifies devices to identify and place them into groups like cameras, IP phones, workstations, and mobile devices. ISE also profiles devices for deeper visibility and adds context. Let's click on this Profile tab. Here we see that ISE has profiled and is tracking Apple iPads, iPhones, Windows 10 workstations, and a lot more. But if we want deeper visibility, we can click on the Apple iPad on the circle chart. This way we can investigate the iPads in our network to add context, like who's using them and where they're located. If we scroll down here, we're going to get a little bit more details on these users. Let's pick one user, P. Boyd, and let's see what he's up to. Here we get details on this user. We see that P. Boyd is Parker Boyd, and is using an iPad, a MacBook, and a Motorola device, and it looks like he's connected in the Tokyo office. As you can see, ISE provides deep visibility into who and what is on your network, where they're located, and a lot more. We've seen, for example, all the specific devices that a particular person, Parker Boyd, is using and where he is using them. And now we can use this information to secure network access through authentication and authorization policies. Now, you might be asking yourself, how did ISE get the identity information of Parker Boyd? Well, ISE is designed to integrate with external identity sources like Microsoft Active Directory. Most companies make AD integration one of their first steps. So with ISE 2.7, we added a new interactive help feature to make ISE administration just this much easier and faster. Now let's go click on the blue interactive help bar and see this in action. Now once we click on the blue active help bar, we can add a Cisco ISE node to a new Microsoft Active Directory joint point by clicking here. And right away, ISE is showing us where to add a new integration. Want to integrate with AD? Just click here. Now, if you need to verify an existing integration's operational status, you can click here on this dCloud link. And we can see here with this green check marks that it's operational. So remember that asset visibility is about gathering information and context about users and devices so that you get a complete picture of who and what is connecting to your network. And integrating with Active Directory is an important way of achieving this goal. I'm going to click on Identity Services Engine to return to the home screen. Now that you know who and what's on your network, ISE enables you to enforce the right access for your users and guests based on your organization's security policy and business objective. The first step is authentication, to ensure that they are who they say they are. The next is authorization, allowing or restricting network access based on their role or status within the organization. Now let's take a look at guest users. Every organization has visitors or guests who need basic internet access. When we click on guest users, we can see who has access to your network and how. For example, if we scroll down, we see a list of guests who receive access through a sponsor. That is someone in your organization who has granted them with guest access credentials. In the interface, you have a number of details: username, location, and authentication policy. Here we see that the guests were required to use 802.1x, an industry standard that submits access credentials to ISE. Then ISE recognized those credentials as valid guests, so it automatically assigned them to a sponsored guest authorization policy. So in other words, ISE told the wireless access point to grant these users only basic internet access, and for that specific period of time. Now back in the Authentications box, we can click on the internal endpoints, and by scrolling down, we can see a summary of internal authentications. And the details below, you can see the devices that ISE profiled and classified as a Xerox printer. Now, a printer is a good example of a headless device. That is one that doesn't have an end user, but one that still requires authentication. Now, how can you authenticate if there's no person there to submit credentials? That's easy. The printer's authentication policy is MAB, or Mac Authentication Bypass, which is one way that ISE controls access for headless devices. You can simply define an authentication policy that states, allow a device classified as a Xerox printer if the MAC address is in this specific whitelist. Let's take a look at segmentation. ISE uses the network itself to enforce segmentation, which limits or blocks access to resources based on the principle of least privilege, also known as a need-to-know basis. For example, your security policy might permit facility engineers in your building IoT group access to your building's IoT devices, but not to your payment processing systems in that PCI group. Now, PCI auditors need access to the PCI group, but there's no reason for them to access your building's IoT devices. Now, if we go to Work Centers, TrustSec, and then TrustSec Policy, we see the policy matrix that makes it easy to see who's allowed to communicate with what. And if we look here, auditors are clearly denied access to the building's IoT devices, but they can access the PCI servers. Now, IoT, as you can see right here, cannot access those PCI servers, but they have a level of privilege that they need to communicate with other IoT devices. Note that we also define one security group access control list called block malware, which blocks the typical ports like SMB on port 445 that are exploited to spread malware like WannaCry. It's a simple example of how we can use segmentation to enable access, yet limit the spread of cyber attacks across your entire network. Now let's take a look at ecosystem integrations. We all know how important it is for security technologies to work together automatically. Since data breaches can occur in mere moments, Cisco ISE provides a standards-based integration platform called the Platform Exchange Grid, or PX Grid for short, to integrate with both Cisco and non-Cisco security products. If we click on Administration and PX Grid Services, we see those integrations and how they're set up. Note that these are integrated through Extensible Messaging and Presence Protocol, or XMPP for short. We were thrilled when the Internet Engineering Task Force declared our XMPP grid architecture as an official internet standard for security information exchange. And now that it's an IETF standard, we expect more and more third-party security vendors to support PX Grid for ISE integration. Now, imagine that one of your integrated security technologies like AMP for Endpoints or Qualys discovers an endpoint with a high threat or vulnerability score. You can configure these products to send high-fidelity indications of compromise, IOC, threat-detected events, and CVSS scores directly to ISE for immediate action. The concept is called Threat-Centric Network Access Control, TCNAC. And here's where you set it up. TCNAC enables you to create authorization policies based on the threat and vulnerability attributes ISE receives to dynamically and automatically control the access level of an endpoint or user. Now let's click on the Operations TNAC live logs. And we see them here in the live logs, what identifies the endpoint, user, and the change of authorization. Now, if we had an action, we'd see the original authorization policy and the new threat-centric authorization policy that's either limiting access or removing the endpoint from the network altogether. This demonstration highlights key capabilities of ISE: asset visibility, secure network access, segmentation, ecosystem integrations, and rapid threat containment. But we didn't have time to show you everything. That's why we encourage you to experience ISE for yourself through the video walkthrough demonstration right here on DemoZone, and to check out our ISE page on Cisco.com. Now, I appreciate your interest in Cisco ISE, and thank you for your time today.